Hi everyone, and thanks for having me again in this HackaLOD meeting. Unfortunately, I'm not able to join live today, but I'm very glad that I can still share my results with you today in this pre-recorded video. So, some of you might remember me. My name is Simon, and I'm researching the interestingness of artwork relations, and then specifically for art museum visitors. So, last time I was here, I asked you to join my experiment, which was about artwork relations, and I showed you 25 relations between artworks, and I asked you to rate them on interestingness to gather some data. Well, 320 participants have joined, which is amazing, so thank you all for joining. I had a lot of good results, and today I can share some of those results with you. So now that I know a little bit more about the artwork relations that you find interesting, I can look at how I can predict that interestingness using Wikidata. So a quick disclaimer, this is academic research, so it's my master's thesis in artificial intelligence, but this is not an academic presentation. So don't tell my supervisor, don't tell Linda. It's more of an informal update on what I've been up to and not necessarily the end results. You might be wondering, what were the most interesting relations I found? And this is the one at the first spot. It's the same location of point of view between these two works. So on the left you see this little building and it matches with the one here. These two paintings were created from the same point of view, and generally people consider this interesting. Here's another example that people found interesting. It's two artworks and the same model posed for these artworks. And one that people did not find interesting at all is this one. Two artworks and they both depict a mountain. Well, here it's really in the background and here it's also a bit in the background, so this people did not really consider interesting. And it got me thinking, what is it that makes artwork relations interesting for art museum visitors? And it's really hard to point out exactly what this is, because it's so subjective. It might depend on your visiting motivation. So if you go to a museum and you're socially driven, maybe you care about different things than someone who goes there because he's really interested in the artworks. And it might also depend on your background or experience level. So if you're an art historian, you probably find different things interesting than someone who's not an art historian. My hypothesis then is that some relations referring to Wikidata classes are more interesting than others, and I'll explain what I mean. So here's a relation between two artworks and they both used oil paint as a material. So oil paint on Wikidata, it's Q296955. So this artwork relation, it refers to oil paint. But oil paint is an instance of a painting material. And painting material then is a subclass of art material. And art material is a subclass of material. So you could say that these artworks were made using oil paint, this relation between two artworks, well, it refers to the Wikidata classes oil paint, painting material, art material, and material. And then my idea, my hypothesis is some referred Wikidata classes are more interesting than others. So for instance, maybe art museum visitors typically care a little bit less about relations referring to locations and care a little bit more about relations referring to people or to other artworks. So what's the idea then? On the left here on the screen, you see the 136 artwork relations ranked by interestingness by the 320 participants that joined. So at the top here, you see same point of view as at the top because people found this the most interesting, and depicts mountain is at the very bottom because people didn't care for it generally. Then an idea to estimate this ranking is to sort on the person Wikidata class. So what we do, we create a heuristic and we say, okay, take these 136 and sort them based on the people Wikidata class. So at the very top, there's only the relations that refer to people. So in this case, same sitter because it refers to a model, a person, and student of because it also refers to a person. And then at the bottom you have all the relations that don't refer to people. And you can compare these two. So on the right, this is trying to estimate what's happening over here. Estimate or predict the interestingness. And then with these lines, we can see how well it is doing. So if we take a look at the one relation that's supposed to be in first place, we see that in the heuristic one, it's at the very bottom. So that's pretty bad. It's a huge distance. But these two, they're doing pretty well because they're only one place off. And this is called the rank distance, and you can consider this as a performance measure for how well our interestingness heuristic is doing. And it's a bit of a simplified explanation, but this is the general idea of the distance measure I used. A lot of technical stuff, but here's the finding, or at least my preliminary finding. A huge graph, and what you see here on the bottom are the Wikidata classes that the heuristic refers to. So for instance, a relation referring to a location or an organization. Then over here you see the distance metric. So lower is better. So the best performing interestingness measures or heuristics are at the very left here. And what you find is that classes that help to predict interesting relations are relations that refer, for instance, to people or to other artworks. So for instance, a relation referring to a person is the one I showed earlier, where two artists are both a student of the same person, so then it refers to a person. Classes that help to predict uninteresting relations are also of value because they can help put the uninteresting ones at the very bottom of the ranking list. So those are the ones that refer to locations or museums. So for instance, there's one relation between artworks that says these two artworks were both exhibited at the Louvre Museum. And people didn't really care for it. And I think that is because it doesn't really tell the story of the artwork itself, but only about what happened afterwards. So what I showed here is sorting on just one variable, so putting people at the top and the rest at the bottom, but you can also sort on multiple variables. So you can say, okay, put people at the top and locations at the bottom, and then you can keep going like this, and you see that if you include more variables, then the performance increases, so the distance decreases in this case. That's one finding. It might be a bit technical for some of you, but there is one finding that's really intuitive actually, and that's that common values negatively seem to correlate with interestingness. So as an example, again, these paintings were made using oil paint. Well, it's a relation, of course, but intuitively it's a bit boring, right? And how do we estimate this using Wikidata? Well, we know that on Wikidata there's about 500,000 paintings. We also know that on Wikidata there are about 270,000 paintings of which we know the material that was used. And then on Wikidata, the paintings that were made with oil paint is 247,000. So we can calculate a couple of numbers. Of all Wikidata paintings, how many were made with oil paint? It's more than half of them. So of all paintings, more than half of them were made with oil paint. But of all Wikidata paintings of which we know the material that was used, how many were made with oil paint, it's over 90%. So when we know the material of a painting on Wikidata, it's almost always oil paint. So it's a great measure for interestingness in this sense, because the really common values, they're not interesting because they occur so often. So this tends to be pretty good at eliminating the very uninteresting relations. Yeah, exactly. So it seems to be helpful for identifying uninteresting relations. And it also works for these artists were both painters, because there are a lot of painters on Wikidata. Again, a disclaimer, these are two findings that are preliminary, but they seem to be true. It's not an academic presentation, but if you're interested in the full story, then you can join on June 24th. Just shoot me an email with the email on the screen here. And then, yeah, if you have any questions, please let me know. Unfortunately, I'm not able to join live, but I'm very curious to hear your thoughts and questions and comments on my work so far. Thank you, and have a great rest of the day. Bye.